The project began in 2014 to investigate how the ocean, specifically its thermal and salinity properties, can affect the intensity of tropical storms and hurricanes, particularly in the Atlantic Ocean and the Caribbean Sea.
Is the glider ready for the first dive? We're ready here. Okay, we'll proceed with the first dive to 45 meters. It will take 15 minutes.
The underwater glider is an oceanographic instrument for observing how temperature, salinity, and other oceanic parameters fluctuate from the surface layer down to a depth of 1,000 meters. Operations also include a team of glider pilots and engineers. In the laboratory, staff scientists communicate with the gliders, directing them where to go, how to carry out the observations, and verifying that these are being transmitted and assimilated into the forecast models.
We're good, looking good. Okay, field team, the glider is good.
Esta misión propone lanzar 4 gliders de los que son propiedad de NOAA, del AOML, y en adición 5 adicionales que proveyó el Navy, la oficina naval del Navy. Lanzamos 2 en el sur de Puerto Rico, que cubren la región de Caricoos. Se van a hacer 5 lanzamientos de gliders del Navy en el norte y 2 de gliders de AOML, Caricoos, en el norte también. En adición, se van a lanzar 5 de ellos en el área de las Islas Vírgenes norteamericanas. En total serían 14 gliders que estarán operando en la región en esta temporada huracanera.
This project began in 2014 with 2 gliders, one monitoring in the Caribbean Sea and another in the tropical Atlantic. Over the years, due to the good results obtained and the support from NOAA, operations have expanded.
We have access to historic hurricane trajectories. We have focused our attention on conducting glider observations in places where we know hurricanes are going to travel and potentially intensify. This helps us increase the probability of having our gliders near where hurricanes may travel during the hurricane season.
The primary data being gathered are for temperature and salinity, ranging from the ocean's surface layer down to a depth of 1,000 meters. This is very important because conditions found not only in the ocean's surface but also below are linked to the intensifications of hurricanes. In general, the higher the heat content in the ocean, the greater the possibility that a hurricane will intensify. Salinity, however, also plays an important role. When seawater has less salt, its surface is more stable. This makes it more difficult for hurricane winds to mix all the waters in the upper ocean. This, in turn, can create a larger difficulty for surface water to cool down through interaction with the colder subsurface waters, and a hurricane may potentially intensify.
We have a mission. You can go back now.
Engineers and scientists who gather data from the gliders work very closely with scientists from NOAA's National Weather Service, developing numerical models to predict the intensity and trajectory of hurricanes.
So we have fairly good measurements of the ocean surface from satellite data, from ships at sea, and also from buoys and the glider data. However, the observations of what's below the surface are much more sparse. We have very big gaps in the ability to look at the ocean temperature, say down to a few hundred meters, which affects tropical cyclones. The salinity measurements are even more sparse. And again, those more of a second order effect for tropical cyclones, but again, they can affect how the ocean interacts with the atmosphere. So we definitely need more information on the subsurface ocean structure of both temperature and salinity. It's very important that we measure those accurately and model those accurately to give us the best possible forecasts.
Carrying out these observations is a very complex process. It requires the collaboration of experts in multiple fields to evaluate and assess the impact of these and other ocean and atmospheric observations.
Caricoos forma parte de IUS, que es el Sistema Integrado de Observación a nivel de Estados Unidos, nacional, y apoyamos operaciones de NOAA, otras operaciones de NOAA en nuestra región. Proveemos apoyo logístico y además de eso proveemos algún conocimiento local científico que pueda asistir en la operación. Esto lo hacemos nosotros, inclusive lo hacen otras regiones. Aparte de eso, tenemos estudiantes graduados del recinto de Mayagüez de la Universidad de Puerto Rico y tenemos estudiantes inclusive subgraduados que tenemos a bordo entrenándose en esta LIDE. Es importante señalar que mucho del trabajo de optimización, afinamiento o tune-up de los instrumentos se lleva a cabo aquí con estudiantes que han sido entrenados y han tomado los cursos para hacerlo, y esperamos ampliar ese grupo de trabajo que pueda asumir la responsabilidad en operaciones futuras.
We feel like the modeling systems now are to the point where they can make use of that data. The resolution is fine enough so that we can properly include those in the prediction. So having access to this new data source is going to be very, very important for us going forward into the future to make our forecasts even better than they are now.
This multiple agency effort increases the chances that these gliders will be in the path of hurricanes for study, and will contribute to expanding observations in support of improved hurricane intensity forecast models.